Okay, so now we have this data entered L1 and L2, and what we're going to do now is we're going to graph it. So hit y equals, and if you have anything in the y1 or the y2, then you need to clear that out because we're not graphing a function, we're graphing a scatter plot. So go up all the way to the top so that the cursor is blinking on top of plot 1, and then hit enter. So now if you came back down, it should be highlighted, okay? And then the way that we're going to graph this in a way that we get all the points so that we can see them is if you hit zoom 9, then all of the points that we have graphed will be nicely displayed, okay? Very nice. Now we good job. All right, so now if you would turn to page 138, you will see a very important list of graphs. Have lines connecting all your dots, and you don't want lines connecting all your dots, then you need to go to second y equals. And if you hit enter, then you can decide how you want your points to be graphed. I have mine unconnected, so I have a boring basic old scatter plot, which is what we want. It sounds like Evan has a line plot, so this piece right here is highlighted. So scroll down and highlight the very first one. You could also make a bar graph. You could make your old friend a box and whisker graph, or you could make a step function, but we just want the scatter plot. So you should be able to get it so your graph looks like that. Okay? Okay, so we're going to model this data with a particular type of function, and all of our choices are on page 138. Okay? So we have linear functions, which is the data looks like it's a straight line. We have quadratic functions, which is parabolic. Cubic, which goes up and then down and then back up again. Or quartic, which goes down, and back up. And those four functions are the types that we're going to study in the next chapter. And then we have some other choices: natural log, exponential, power function, logistic, and sinusoidal. Okay, so those are all of the different kinds of sinusoidal. Those are all the different kinds of functions that the calculator can come up with. You always want to choose the simplest one. What does this look like?
Linear.
Pretty much linear, okay? So the way we're going to find the linear function that goes with this data is you're going to hit stat again, hit the stat button again,
Stat. Calc.
and then scroll over to the right to the calc menu, and we chose linear, which is number 4. So hit number 4, and then hit enter, and that gives you the equation of the data. Okay? You have to go to the very bottom and then hit enter.
So we go linear.
Okay.
What is wrong with
So one more time, go stat, over to calc, hit number 4, and then hit enter, and it should give you the A is the slope.
I just got Y and B.
I got Y8.
That's what I got.
R squared.
Okay, oh yeah. You don't need to have this, we'll talk about that later, okay? Some of you might have it. Okay, so this gives you the equation for the line, okay? So let's round this a little bit, let's simplify it. So you guys keep yours up. So why don't you give me what A was to 2 decimal places?
0.96.
0.96. Do we round up?
No. 7.
97, okay, so 0.97x plus, what's B, what's the y-intercept?
23.01.
23.01? Okay. So there's the equation of the line that best fits that data. So now if we go back to our calculator, we hit y equals, and type that in there, 0.27x plus 23.01.
0.97.
Thank you. 0.97x plus 23.01. Now if you hit graph, you should notice that you have come up with the trend line for that data, okay? Or the regression line. We'll talk later. Okay, and so now you can use this to make a prediction. So it says, if we use this prediction, what are we trying to figure out? Oh, use this function to predict the high temperature that day for Madison, Wisconsin, the city of my birth.
No, that's a joke, right?
No, that's
I
where
thought
I
you
was
were
born.
born in the ghetto.
He's lying.
I grew up in the ghetto. I was born in Madison. Yes, I was.
Plug into the streets of Michigan.
I grew up in inner city Minneapolis. If I played, you knew we were going to win. Okay, so if in Madison, Wisconsin on the same day the low temperature was 46 degrees, we're going to use this function to predict the high temperature for that day. How do we do that? Plug it in for the X or for the Y?
X.
How do you know? How do you know the X's were the low temperatures? What did we do when we were setting this up that told us that the X's were the low temperatures?
We always
What's
put it
the
in
9
X, that's why.
What? L1 is the X's, L2 is the Y's. And we put the low temperatures in L1, so that means our X's are the low temperatures. So if I go 0.97 times 46 plus 23.01, then we find out that our model would predict the high temperature for that day to be approximately around, you can do the math yourself, 68 degrees. And they say in the book, the actual retail value was 67 degrees. So it's a pretty good model that we came up with.
Erica wants to talk to you.
Okay? I know she does.
67.
Erica, what is it?
Oh,
Okay, just two problems because they're long ones. They have a lot of A, B, C, D stuff. I said they have a lot of A, B, C, and D